Hello everyone. Uh, Here we'll be discussing today's class will be mainly based on numericals, and we have finished the chapter, so we'll be solving numericals only in this. Okay, so numericals we'll be solving in this class. Okay, so let's write questions. First question: discuss the conditions. I hope you have studied the theory. So discuss the conditions for these operators. For these operators to be unitary. To be unitary. A 1 plus I A cap divided by 1 minus I A cap A plus I B cap divided by A square plus B square. Okay. So 1 plus I A cap divided by 1 minus I A cap A plus I B divided by root over A square plus B square. Okay. So we have to check whether these operators, like we have to check the condition for which these operators will be unitary. Okay, unitary. So let's solve it. So we know an operator U, okay, is unitary when it is unitary only when U dagger is equal to U dagger into U, that is equal to I like unit matrix, okay, or unit operation. Okay. So let's see first one. First one is a what? Just like this 1 plus IA by 1 minus I. This is the first one, like first operator. So let's calculate its dagger. So its dagger will be what? Suppose this is a U. Dagger is U dagger is 1 plus IE divided by 1 minus IA. Dagger is equal to minus will be, this one will become minus, this one will become plus because this is I. So this is complex conjugate actually. So plus I. Yeah. So now what we have to do, we just have to multiply and check whether it is becoming I. Okay. So U into U dagger is equal to 1 plus IA minus IA into 1 minus IA by 1 plus IA. Okay. Also we have to check what? Like the opposite thing also. Okay. Let's see first. This is cancelled. This is cancelled. So this is I. The other thing also, the other way around. The U dagger into U will be what? 1 minus IA. 1 plus IA. 1 plus IA. 1 minus cancelled out, cancelled out. That's okay. This is all right. So this is your what unitary operator. Okay, so this is operator is an unitary operator because we proved that U dagger is equal to U dagger U is equal to I. Okay, is it all right? Okay. Next operator was what? A plus IB A square plus B square. Okay, let's see this one. A plus IB divided by root over of A square plus B square. A square plus B square. So here, um, what? What will we do? See here, if A and B are Hermitian, okay, and they commute, then the expression will become unitary. Supposing their like dagger will be what? Okay, suppose again this is U. So U dagger will be A minus IB divided by A square plus B square, right? Isn't it? Hmm. So U dagger will be what? A plus IB divided by A square plus B square into A minus IB A square plus B square. Okay. So this becomes what? This becomes okay. I cannot just do that. Okay, the one you do usually. So this one will become A square minus I A B plus I B A minus plus B square whole divided by A square plus B square. Okay. So this becomes A square plus B square minus I or plus I into AB little mistake. Okay, minus I suppose. Minus I AB minus BA. Okay, divided by A square plus B square. So we have as if see when it will be I, when this thing will be I, when this term is zero. When this term is zero, then only they will be cancelled out. It will give me I, right? I means unit operator. So when it is zero, when it is zero, when this they commute with each other, then only this is zero, right? Right, this is the formula for this. So we can write A and so is zero, then it becomes what? A square plus B square divided by A square plus B square. So this one will give me 1. Okay, sorry, I. 1 means I. So the condition is what? The condition is A and B should be Hermitian and they should commute with each other. Should commute. Commute means their commutator is 0. Okay. Is it alright? Next question. Next question. Question number 2. So that the operator A is equal to I square plus 1 dy dx plus I square into Hermitian. Hmm. Find the state. Find the state psi x for which A psi x is equal to 0 and normalize it and normalize it. Okay. See, calculate the probability. Calculate the probability of finding the particle. Finding the particle represented by psi x represented by psi x in the region in the region -1 to x to 1. Okay. Yeah. So that the operator A is equal to this A is Hermitian. First of all, you have to show this is Hermitian. Find the states Ix for which this is equal to 0 and normalize it. Calculate the probability of finding the particle in the region -1 to x to 1. Okay, let's try this question first. Let's try this question first. So that the operator A is equal to this A is Hermitian. Find the state for which this is equal to 0 and normalize it. Calculate the probability of finding the particle in the region -1 to x. Okay, so try. Let's first do the first one. That is, we have to show this is Hermitian. So what is given? A cap is equal to is given I square plus 1 dy dx plus I x cap. That is, we have to show Hermitian, isn't it? You have to show Hermitian. So you have to know that x cap position operator is Hermitian. Okay, but the dy dx dagger is minus dy dx. Okay, just have to remember this. Okay, so we have to use this here. So if I say a dagger, that will be, what will be the one? The first one will be minus I x square plus 1, but this one will become what? Minus dy dx. Okay, as I said here, and this one will become minus ix. Okay, isn't it? Hmm. Is it right? Um, okay. Okay. Next, let me open it. Okay, minus I x square into minus dy dx minus I into 1. This is plus 1, na? Plus 1 into minus dy dx. Okay, and minus ix. So this is minus plus I x square dy dx plus I dy dx minus ix. Okay, so if you see, this is actually I x square plus 1 dy dx. I could have done it there, but just let me I just opened it a bit. Minus ix. Okay, so mm now what? Okay, there is one thing here. Um, this one I have to do a bit differently here. This term won't be written like this. Okay? Or, I have to do it again. I think this this is not right. I'm sorry. Let me do it again. Okay. Again, I'll write a cap is equal to um, I square plus 1 d by dx is ix. So, so a dagger I will write as minus I d by dx dagger x square dagger minus I d by dx dagger minus I x dagger. Got it? This much clear? This one I have just written minus I d by x dagger x square dagger plus 1 na? So minus I d by dx dagger minus I. Okay. So now I can write it as I d by dx of x square. Your d by dx dagger is minus d by dx and minus minus plus. This again minus minus plus, so my plus I d by dx minus I x cap. Okay, here what will happen? I will write it as I x square d by dx. Okay, plus I d by dx and x square commutation. Okay, I will write this my plus I d by dx minus ix square. Okay, what I did here, if you see, this commutation is what actually I d by dx x square commutation is how much? If I open it, it will be d by dx. I have to take psi. Okay, x square psi minus x square d by dx psi. Okay, so that will become I. This is 2x and the psi plus x square d psi by dx. Okay, minus this is also minus x square d psi by dx. So this cancelled out. So what is left? 2, sorry, I 2x psi, isn't it? So this is what is left. So this is actually what I into 2x. Okay. No. 2x. Yeah. Um, yeah. And mm, yeah. So we will put in this place. We will put this. Okay. We will put 2x. Right. So if I put 2x there. Let's put it there. 2x. See, you will see something very good. Yeah. Dagger is equal to I square dy dx plus I 2x plus I dy dx minus ix. So if you see 2ix minus ix is ix, isn't it? So I will write it as ix square dy dx plus this one I dy dx plus ix, isn't it? So this is what a is, isn't it? This is also a. I've just opened the bracket here. So I x square plus 1 d by dx, sorry, by dx plus ix cap. So this is your what? A. So a cap is what? Emission, isn't it? Clear? Okay. Okay, next, what was the next option? Like second bit in this question. Find the state psi x for which, okay, a psi x is equal to 0 and normalize. Okay. Find the state psi x for which a psi x is equal to 0. Okay, and that means what? A means we have written a, right? We have been given a actually. I, in the first bit we are given I x square plus 1 d by dx plus I x square. So it is asked state psi x for which a psi x is equal to 0. So that means what? I will just apply this operator on psi I x square plus 1 d by dx plus I x cap psi x is equal to 0, isn't it? Okay, is equal to 0. So I will open the bracket. So if I open the bracket, I x square plus 1 d psi by dx plus I x cap psi x is equal to 0. Okay. So this is 0. So I will take the, like, I will arrange it a bit. X square plus 1 d psi by dx is equal to minus I x psi x. Okay. So I cancelled out. So I can write it as d psi by dx, d psi x, whatever, d psi by dx is equal to, this will come to this side. So x by minus x by x square plus 1 psi x. Okay. Isn't it? Okay. Is it alright? Hmm. Okay. So, mm, okay. So how to do it from here? You have to solve this differential equations, and if you solve it, you will get it as psi x. You will get the solution as psi x is equal to b root over of x square plus 1. Okay, you will get the solution as b root over of x square plus 1. Okay, so now we are asked what? Find the state for which this is 0. So this is the state, and normalize it. Let's normalize this. This is the state. So if we normalize it, that means what? Integration minus infinity to infinity psi star x, psi x is equal to 1. So minus infinity b by x square plus 1 into b by x square plus 1 root over dx is equal to 1. Okay, dx is equal to 1. So b square comes out, integration minus infinity to infinity 1 by x square plus 1 dx is equal to 1. Integration, so b square, integration 1 by x square plus 1 is tan inverse x. So tan inverse x minus infinity to infinity is equal to 1. So b square tan inverse infinity minus tan inverse minus infinity, okay, is equal to 1. So tan inverse infinity is pi by 2, because tan pi by 2 is infinity, minus tan minus infinity is minus pi by 2 is equal to 1. So b square pi by 2 plus pi by 2. Tan pi by 2 is undefined or infinity. So tan inverse infinity is what? Pi by 2. Exactly same for minus pi by 2 is equal to 1. So b square into pi is equal to 1. So b is equal to what? 1 by root pi. B is equal to 1 by root pi. Okay. So the wave function becomes what? Psi x is equal to 1 by, sorry, b by root over x square plus 1. So it becomes 1 by root over of pi whole into x square plus 1. Is it clear? Okay. Next, what is that? What's the question in the next page? Find the probability of finding the particle in the region -1 to x1. Probability of finding the particle in the region. Okay. Probability of finding the particle in the region. So how will I find it? Simple. So third bit. So probability of finding the particles. Probability is finding the particle -1 to 1. Okay. Psi x square dx, isn't it? So if you do it -1 to 1, what is the 1 by root pi x square plus 1? We got it in the last bit dx, isn't it? Hmm. So if you see -1 to 1, 1 by pi x square plus 1 whole square. Sorry. Root over root over, yeah. So 1 by pi -1 to 1, 1 by x square plus 1 dx. The integration of this is tan inverse x second. So 1 by pi tan inverse x limit -1 to 1. So 1 by pi tan inverse 1 is how much? Pi by 4. Tan pi by 4 is 1. Minus tan inverse is minus pi by 4. Okay. So 1 by pi by 4 plus pi by 4. Okay. So that will be pi by 2. So 1 by pi into pi by 2. This is 1 by 2. Okay. The answer is 1 by 2. Is it clear? Yeah. Okay, good. So this is the probability. Easy question. Hmm. Just have to derive it a bit. Just see whether you're able to solve it or not. Let me know. The next question right now. Next question you try to solve yourself. Question number 3. Consider a state consider a state psi is equal to 1 by root 2 phi 1 plus 1 by root 5 phi 2 plus 1 by root 10 phi 3, which is given which is given in terms of three orthonormal three orthonormal eigenstates three orthonormal eigenstates phi 1 phi 2 phi 3 of an operator B such that B phi n is equal to n square phi n Okay, find the expectation, find the expectation value of b, okay, for the state psi. Consider a state psi is equal to 1 by root 2 phi 1, 1 by root 5 phi 2, 1 by root 10 phi 3, which is given in terms of three orthonormal eigenstates phi 1, ket, yeah, ket phi 1, ket phi 2, ket phi 3 of an operator b such that b phi n, when b operates on phi n, it gives me n square phi n. So find the expectation value of b for the state psi. Try this question. Mm. Try this question. Consider a state psi is equal to 1 by root 2 phi 1, 1 by root 2 root 5 phi 2, 1 by root 10 phi 3, which is given in terms of three orthonormal eigenstates phi 1, phi 2, phi 3 of an operator b. So that phi b phi n is equal to n square phi n. Find the expectation value of b for the state psi. Okay. Let's try this question. If we try this question, okay. So we can write the expectation value of b. How can we write it? Psi b psi by psi. Okay, we can write like this. First of all, let's write calculate the psi. So this would be your 1 by root 2 bra phi 1 plus 1 by root 5 bra phi 2 plus 1 by root 10 bra phi 3. Okay, and upon it I will operate ket. So 1 by root 2 ket phi 1 plus 1 by root 5 ket phi 2 plus 1 by root 10 ket phi 3. Okay, so that will give me 1 by 2 plus 1 by 5 plus 1 by 10, isn't it? 5 1 5 1 will be 1 everything. So LCM is 10, 5 plus 2 plus 1. So this is actually what? This is I'm getting at what? 8 by 10. So this is not normalized actually. Okay. Now psi b psi will be what? We know when b is operating on psi, it will give me what? N square psi, isn't it? Because it's operating on phi, it is giving me n square. So again, I will write it as 1 by root 2 bra phi 1 plus 1 by root 5 bra phi 2 plus 1 by root 10 bra phi 3. Okay, and b will operate on it, and and it will operate on the kth part phi 1 plus 1 by root 5 phi 2 plus 1 by root 10 phi 3. Okay. So when b operates on phi 1, it will give me, see, b phi n is n square phi n. Okay. So if it is 1, it will give me 1 square phi 1. So 1 by root 2 into this 1 by root 2, b will act on phi 1, that will be 1 square. Yeah, phi 1, this is phi 1 is gone. Yeah, 1. Now 1 by root 5 into 1 by root 5 into this b will act on phi 2, that means it will give me 2 square, plus now 1 by root 10 into 1 by root 10, and b will act on phi 3, that will give me 3 square. Okay, so that is 1 by 2 plus, if you calculate it, 4 by 5 plus this is 9 by 10. Okay, I take the LCM as 10 again. 10, this is 5 plus 8 plus 9. So this is 13. 13, 9 is 22 by 10. 22 by 10. So the expectation value we know is what? Psi, we have written in the beginning, psi b psi divided by psi psi. Okay, psi b psi, I just got 22 by 10, and psi psi is how much? 8 by 10. Okay, 8 by 10. So the expectation value is 22 by 8, that is 11 by 4. Okay, that is the answer. That's the answer. Okay, question number 4. Calculate the following expressions. Calculate the following expressions involving involving Dirac's delta function. Okay, first one is minus 5 to 5 cos 3x delta x minus 5 by 3 dx 0 to 10. Okay, we'll do one by one, no problem. First do this question. Solve it. Calculate the following expression involving Dirac delta function. So we have to solve Dirac delta function here. Minus 5 to 5 cos 3x x del x minus 5. Okay, see. The formula is fx del x minus x naught dx. Suppose there is this value a to b, and this x naught actually lies between a to b, then what will be the answer? The answer will be f x naught. Okay, we'll just put this x naught in place of fx. So exactly we'll do this here. Minus 5 to 5. Tell me, pi by 3 lies between minus 5 to 5 or not? Pi by 3 means what? 3.14 by 3, something around 1.04 or something. So 1.04 lies between minus 5 to 5. So I can do it as cos 3x delta x minus pi by 3 dx. So pi by 3 I can directly put here. So cos 3 into pi by 3. That means 3 3 gone, cos pi. Cos pi is what? Minus 1. So answer is minus 2. Okay, is it clear? Is it clear? I hope it's clear. Okay, next question. Next question is 0 to 10. Integration 0 to 10. E to the power 2x minus 7 plus 4 delta x plus 3 dx. Okay, try this question. Okay, see here, this x plus 3 is equal to 0 if I write. Hmm. So x is equal to minus 3. So x is equal to minus 3 does not lie between 0 to 10, does it? So the answer is 0. If the this thing doesn't lie between this one, then it will become 0. Okay. Next question. Uh, Next is what? Just 2 cos square 3x minus sine x by 2. So what will happen here? Hmm. So x plus pi, that means x plus pi is 0, x is a minus pi. Okay. So 2 cos square 3 minus pi minus sine minus pi by 2. Okay. So this will give me what? Del x plus pi. So 2 cos square uh, 3 minus pi is what? Cos square means cos square 3 pi. Right. Cos square 3 pi minus sine, okay, plus sine pi by 2. Hmm. And whole into del x plus y. Okay, cos square cos pi is minus 1, cos 3 pi is also minus 1. So minus 1 square is 1. So 2, this is 1, whole into delta x plus pi. The answer is what? 3 delta. Is it clear? Okay. Okay. So these are some of the Dirac delta questions, right? That you should practice. Now the question right for homework would be 2 to 9 mitigation 2 to 9 x square minus 5x plus 2. Okay. Delta to x minus 4 dx. Right? Yeah. So this is the homework. And try this question. Try this question, and I hope you can solve it. Okay. And that'll be it for this class. Okay, we'll be solving more questions in the upcoming sessions. Okay. Thank you very much.